That's number one. This for the maths. For the math is a binary operation. Operation star is defined on the set of real of R, on the set R of real numbers by m star n equals m plus n plus 2. Then we should find the identity elements under the operation, and B, you find the inverse of n under the operation star. Now the identity element, in trying to find it, I could say let E be that identity element. Let E be the identity element. Such that E is an element of a real number. That means E, the identity element, is also a real number. Because if the identity element is not a real number, then this doesn't exist. It has to be a real number. And here's what happens. If we have such identity element, then under the operation m star E should give us n. And it should be commutative such that the placement doesn't matter. So m star E, the identity element, should give you n, and the identity element star n should still give you n. You can take it from anywhere to find the identity element. Okay? Now, the operation is defined as m plus n plus 2. So it means m star E will be m plus E plus 2, which is still n. The operation is defined as. And you wonder, okay, why did I put E here? Because the second, which is n, is taking this place. So whatever comes here should take n. Whatever comes here. Okay, so if you're going to solve to find your E, you just take this part. And let's say we're ignoring this part now. We've gotten what you want from it. In solving this equation, we have E to be m minus 2. And obviously, m minus m is 0, so E is simply minus 2. Therefore, the identity element is minus 2. The identity element is minus 2. Now, the next question says find the inverse of n under the operation star, the inverse of n. So, permit me to wipe. I can wipe. Okay, let me wipe the first part. This is A. We just finished A. Now, B. B. The inverse. I can still say let's n prime, an element of R, be the inverse of the element n, which is equally an element of R. That means n is a real number, and so its inverse should also be a real number for such operation to exist, to be true. Okay, so if that's the case, then just know that the identity element results from you merging, or should I say, bringing the inverse and the elements together. So if you bring this element and its inverse under the operation, it should result to the identity element, and it should be commutative, such that inverse first and the original element could still be placed interchangeably. You could switch their positions and it should still give you the identity element. Okay, so this is what we'll be running with. Now remember, the identity element was found out to be what? -2, right? Good. So if that's the case, then let's go back to the operation. N star n prime is equal to, with the operation, n takes the first part, so you have n plus n prime plus 2 should be equal to -2. So I simply replaced m with n, and I replaced n with n prime. And remember I said it's commutative. If we're taking this part, this one, it will still give us the same thing. So let's uphold this part and solve. You're going to see that n prime is going to be -2 minus 2 minus n. -2 minus 2 is -4 minus n. That is the inverse of n. The inverse of n has been gotten. Okay, if that's taken, is it okay? And let's move to the next question, number 2. Now number 2. Number 2 says solve the equation. Solve this equation. 2 cos 2 theta minus 5 cos theta is equals 3. Let's solve the equation. 2 cos 2 theta. And it says for theta between 0 and 360 degrees. Where it lies between 0 and 360 degrees. Solve the equation. So to get this done, solution. Now to get the job done, cos 2 theta. These are trigonometric identity. So you notice it's the same as cos square theta minus sine square theta. It's also equal to 2 cos square theta minus 1 is equal to 1 minus 2 sine square theta. And for what we want, as in solving this question, you can choose to use any of them, but one of them is better. These will take us there fast. This one will take us there fast. So I will choose this. I will be taking this to replace cos 2 theta. And moving on, you have 2 cos square theta minus 1 minus 5 cos theta equals 3. So if you take it up, you have 4 cos square theta minus 2. The 2, you open the bracket. So open the bracket and you have 2 times 2 cos square theta, and you have 2 times 2, 1, 2, minus 5 cos theta equals 3. So collect terms, and that gives you 4 cos square theta minus 5 cos theta minus 2 minus 3. If I'm using the minus 3 in front and the minus behind, it's still the same thing. So I can let's let cos square theta be, we can use any letter. Permit me to use r. Okay, so that means 4r squared minus 5r minus 5 is equals 0. So here you go, you have a quadratic equation to sort out. Quadratic equation. Quadratic equation. All right, just an adjustment, and it's cos theta. Let cos theta be r. And so you see cos square theta can be written as cos theta squared. So that's why you see in r squared here. This is cos square theta. It's the same as this. So cos theta is r, and that gives us so if that's taken, we're going to solve this simultaneously. Now, I'm sorry, not simultaneous, quadratic. We use one of the quadratic methods used in solving quadratic equations to solve this. Permit me to use completing the square method. Using completing the square method, you would want to divide by 4, because the coefficient of the letter with the highest power should be 1. And so since we're having 4, dividing by 4 becomes necessary. So you see you have 4r squared over 4 minus 5r over 4 minus 5 over 4 equals 0 over 4. Okay, so we have, from here we have r squared minus 5 over 4r minus 5 over 4 equals 0. Okay, for one space, I will be wiping the top. So just do well to take notes, and if you've not, that means you wait after the video, you just check back again and play it over. You can pause at intervals. Now this is going to be r squared minus 5 over 4r equals 5 over 4. What happened there was the minus 5 over 4 was taken to the other side of the equation. And you notice it became plus. There was 0 there, plus 5 over 4. Now, this is not necessary. We could do away with all of this. Such that if I do away with the 0, there's a plus, and if plus is the first sign, you can do without writing it. So you have 5 over 4. Now, the next thing you want to do is consider taking half of the coefficient of r. The coefficient of r is minus 5 over 4. That's the coefficient of r. Minus 5 over 4. Now, half of 5 over 4, half of it is going to give you 5 over 8 minus 5 over 8. And so that is half of the coefficient of r. In fact, let me write it. Take half of the coefficient of r. And there you go. Now you're going to add these to r and take the square of both. So I'm adding it to r, take the square. And on the other side, it will be 5 over 4, then plus 5 over minus 5 over 8 squared. These are parts 99% of students struggle with, but I know for you, clarity is coming. So the half is taking this side and you're relating it to r, you're taking the square of it, and then on this side, you're adding square of half of the coefficient of r to the constant that was taken to the other side. So let's stabilize what we have. That gives us r minus, because plus times minus is minus, 5 over 8 squared equals 5 over 4 plus the square of minus 5 is 25. The square of 8 is 64. And if you take the LCM of the denominators, LCM of the denominator is of 4 and 64. 64. 4 into 64. How many times will 4 go into 64? To go 16 times, and then 16 times 5, that gives you 80. And then 64 goes into 64 once, times 25. So moving on from there, you have r minus is equals 105 over 64. Okay, so to get rid of square, take the square root. That means we have taking the square root of both sides gives you the square root of 105 over 64. And then you put in a plus or minus here. If that's taken, I'll still have to wipe the top again. So you have r equals plus or minus square root of 105. The square root of 64 is 8. You have plus 5 over 8 because the minus 5 over 8 can be. You have plus minus root plus 5 all over 8. And then what becomes your answer? Just sort it out for me with your calculator. The plus and the minus values. What did you get? So what's your value? So what you have to translate? Okay, so using our calculator, we round them up to 4 decimal places. R is equals 0. Okay, so let's start with the positive 1.90559 or minus 0.6558. That's the value, these are the values of R. Now, initially we said we took R to be cos theta, and these are the values of R. So that means theta is the cos inverse of R. And then we're looking for the values of theta between 0 and 360 degrees. We're considering the 4 quadrants. Now that means for R equals 1.9059 cos, the cos inverse of 1.9059 will be what? So this doesn't exist, it's undefined. So let's move on to the next. For R equals minus 0.6558, theta will be cos inverse of cos inverse of minus 0 points, but then we could ignore the minus, but having it in mind that we're considering the quadrants where cosine is negative. So we have 0.6558. That gives us 49 degrees, approximately 49. Now 49 happens to appear in the first quadrant where cosine is positive, so it's not one of the values we will accept in this question as theta, because the angle should be negative. It should be in a quadrant where cosine is negative. Now permit me to wipe. We're using theta as 49. Now consider the 4 quadrants. You have the first, and in the first, sine, cosine, and tangents are all positive. That's why I placed all. Now in this quadrant, only sine is positive. For the first quadrant, it's between 0 and 90 degrees. The second is between 90 degrees and 180 degrees. The third, only tan is positive, and it's between 180 and 270 degrees. While the fourth is between 270 degrees and 360 degrees. Cosine is positive here. So we see cosine to be positive here and here. That's the first and the fourth. We'll be considering the value of theta, where cosine is negative. That's the second and the third. So what we do in the second is 180 minus theta, 180 degrees minus theta. That gives you the angle between 90 and 180. And remember, our theta is 49 degrees. To get the equivalent in the third quadrant, it's going to be 180 degrees plus theta. So let's search that. Let's check. 180 degrees minus 49 gives us what? And 180 degrees plus 49 will give us what? For the first, we have 131 degrees, and in this case, we have 229 degrees. So these are the values of theta between 0 and 360 degrees. All right, let's consider the B part. Okay, the B part. For the B part, we have 1 over 1 minus cos theta plus 1 over 1 plus cos theta. It says simplify this expression and leave your answer in terms of sine theta. Leave your answer in terms of sine theta. What you simply do is simplify, as the question says. And let's go ahead and do that. The LCM will be 1 minus cos theta, 1 plus cos theta. And then, using your butterfly method, you have these two multiplying, and then 1 plus cos theta multiplies this 1. That gives you 1 plus cos theta, plus 1 minus cos theta multiplies the 1 here. You have 1 minus cos theta. As your first step. Next, you have 1 plus 1, that's 2. Plus cos theta minus cos theta gives you 0. Now in this case, you have the difference of two squares. That's 1 squared minus cos theta squared, which is as well written as 2 over 1 minus cos square theta. From your trig identities, trigonometrical identities, this is sine square theta, which is the same as 2 over sine theta squared, where sine square theta plus cos square theta is equal to 1. So that means sine square theta is 1 minus cos square theta. It was this we used, this equivalent we used to replace 1 minus cos square theta.